All right. Second review. Ready? This is on our triangle center. Name the segments. Use a median, altitude, perpendicular bisector, or angle bisector. A to D goes from my vertex down to the opposite side at a right angle. My friends, that is an altitude. AF goes to the median once I see that the distance from B to F is the same as the distance from F to C. So AF is going to be a median. GF is going to be a perpendicular bisector. And if the measure of angle BAC is equal to the measure of angle EAC, that means that AE is going to be our angle bisector. I love this question. You might see that figure again tomorrow. All right. A segment from a vertex of a triangle to the midpoint of the opposite sides. Vertex to midpoint is definitely going to be a median. So that is C. A ray that divides an angle is definitely our angle bisector. A line segment array that is perpendicular to the sides of a triangle at its midpoint. Perpendicular bisector. A segment from a vertex perpendicular to the opposite side. My friends, that is an altitude. If P is the centroid, my centroid is a product of what? My medians. Distance from H to P is equal to 8. That means the distance from P to B is half of that. If A to G is equal to 18, 18 divided by 3 is equal to 6. So here is 6, and guess what? Here is 6, and here is 6. So that means the distance from G to P is going to be 12. All right. Perpendicular bisector of BC. Here's segment BC. Perpendicular bisector, hello, EG. Angle bisector of ACB, that's easy. Segment CD. If the measure of angle ACD is 40, what is ACB? Twice that, 80. If the distance from D to F is 6, what is the distance from D to H? Angle bisector. I like that. That one's also got to be 6. How we doing? All right. P is the in center of the triangle. In center is what, my friends? Angle bisectors. So if P is the in center, that means this distance to each of the sides of the triangle is going to be the same. If PO is 8, so is PM, and so is PN. Length of PM, definitely 8. The measure of angle MX, and if I know that MXP is 22 degrees, it's going to be twice that because it's an angle bisector. If the measure of angle XYP, okay, is 20 degrees, what is the measure of XZP? All right, so let's think about that. This is 22 and this is 22, so together that's 44. This is 20 and this is 20 degrees, so together that's 40. So far 84 degrees of my triangle have been accounted for. If I subtract that number from 180, I get 96 degrees left over. So Z has got to be 96 degrees. If I split it in half, that means that XZP is going to be half of this, which sounds a lot like to me to be 48 degrees. What do you think about that? What is the length of x to p? Okay, that's got to be some Pythagoras, because I have an 8 and I have a 12. So 12 squared plus 8 squared is going to be equal to the distance from x to p squared. 144 plus 64 is equal to xp squared. 144 to 64, that sounds like 4 and 4 is 8. Does that sound like 208 to you? So xp, the distance from x to p, is the square root of 208. Now I know 208 has some perfect squares in it. So I'm just going to check my math, because 12 squared is definitely 144, plus 64, 208. 208 divided by 4, and I can divide by 4 again. So it's 13, so xp is equal to 4 roots of 13. How about that answer? 4 roots of 13. That's where that is down here. All right, next up. G is the circumcenter. My circumcenter is from what? My perpendicular bisectors. All right, hello, perpendicular bisectors. They are the same length to each vertex. 13, 13, 13. Ready? And they're bisecting. So if this is 12, so is this. And by the way, do you notice the markings? Here's 12, and here's also 12. So the distance from B to C is going to be 24. The distance from G to C is 13. And triangle GAF is going to be congruent to triangle GBF. GAF, GBF. All right, I love the sometimes, always, never. The orthocenter is, now remember, orthocenter is our altitudes, is blank on the interior of an obtuse triangle. It is never in the interior of an obtuse triangle. If it's obtuse, it's always outside. The angle bisectors of a triangle always meet inside the triangle. The circumcenter, remember, circumcenter is our perpendicular bisectors, is the hypotenuse. So think about that. Remember, when it's a right triangle, the circumcenter is right there. So it is sometimes on the hypotenuse of a triangle. A point on the perpendicular bisector is always equidistant to the endpoints of the segment being bisected. That's true. Hey, we can't forget about our midpoints. Here's our midpoints. In triangle A, B, C, the midpoints of the sides are X, X and Y and Z. Complete the following. All right, XZ, here it is. That's going to be perpendicular to BC. If the distance from A to X is equal to Q, well, that's interesting, then the distance from Y to Z is going to be Q divided by 2, or you can say 1/2 of Q. Either of those answers are good. If the distance from X to Y is equal to 12, then the distance from A to C is going to be 24. If the distance from X to Y is equal to 2X minus 7, and the distance from C to A is 3X plus 8. All right. Now that's going to be separate. I switched colors. And I'm going to come on down and do that work down here. So I know that I have to double xy for it to be equal to that opposite side. So pay attention to how I wrote that. I'm going to double. So that means that 4x minus 14 is equal to 3x plus 8. Subtract 3x from each side, add 14 to each side, and that sounds like x has a value of 22. When I put 22 into that, 3 times 22 plus 8, 66 plus 8, sounds a lot to me like 74. Do we agree? All right. If the perimeter of ABC is 26, then the perimeter of XYZ is going to be half of that. If the measure of angle B is 70, now again, it's another problem, so we'll switch colors so we don't get our markings confused. If the measure of angle B is 70 degrees, and the measure of angle 2 is 56 degrees, what is the measure of angle C? If this is 70, guess what? So is this. Measure of angle 1 is also going to be 70. So that means that 70 plus 56 is equal to 126. 180 minus 126 is going to be 54. Does that sound right to you? 54 degrees. How did you do? I like this worksheet a lot. I hope you paid attention.